Now we have to observe, right? We'll have to make an observation wherein we're looking at the ratios mainly, right? So what is that we can observe in the ratios? Well, opposite by hypotenuse, all the ratios are equal. They're equal to 0.5. Adjacent by hypotenuse, they're equal to 0.87. Opposite by adjacent, they're equal to 0.56, 0.57. Approximately, they're same. So what can we conclude? The ratios are equal or not equal to the other respective ratios. They are equal, right? This is what we can observe. But how can we explain it? How is it possible that all of these ratios are same? What explains it? Similarity, the concept of similarity. It comes under the topic triangles. So wherein if we have one of the angle and a right angle triangle and 90-degree, basically two angles, if they are equal between any set of triangles, all of them are similar. So this is with the help of AA similarity criteria. Okay. So by AA angle similarity criteria, all of these triangles are similar, right? So by AA similarity criteria, all of these triangles are similar. So what can we conclude? By CP ST corresponding parts of similar triangle, the ratios of corresponding sides should be equal. Sides have to be equal. Okay. Right. Now the next question is, actually next statement is, see, we have been calling this ratios as opposite by hypotenuse, adjacent by hypotenuse, and opposite by adjacent. It's a lot of word that we have to tell out. So instead of that, they started using symbols. Not exactly symbols, but names. So when we look at opposite by hypotenuse, it is called a sine. This is cos adjacent by hypotenuse, and that's your tan opposite by adjacent. Okay, so these are your ratios. So the ratios have been given the names, and the names are sine, cos, and tan. When someone tells sine, it is opposite by hypotenuse. If you hear cos, it's adjacent by hypotenuse. If you hear tan, it's opposite by adjacent. These are the ratios that you need to memorize. Okay, if sine is this, cos is this, and tan is this. It's a fixed ratio because triangles has only three sides, so you get actually six possibilities of ratios. And the three are this. The other three are there that we'll see later. But the first three possibilities are this, and they've been given names, that is sine, cos, and tan. Okay. So we have sine, cos, and tan, right? So if someone tells sines, you just have to tell, okay, we're talking about opposite by hypotenuse. If someone tells cos, it's adjacent by hypotenuse. If someone tells tan, it's opposite by adjacent. Right? Now, will the ratios be same if the angles changes from 30 degree to 45 degree? Well, this is 30 degree. If I change it to 45 degree, okay, so not exactly that, but yeah, something like this. That's your 45 degree. Will the ratios be same or different? See, the thing is, if this is 45 degree, if this angle is 45 degree, this is fixed. This is 90 degree, it's a right angle triangle. This has to be 45 degree. Angle sum property. So what we are looking at is an isosceles right angle triangle. So adjacent and opposite side has to be equal. So basically tan value will be 1. So with this in mind, we can clearly make a note that yes, they won't be the same. So if I change the angle, the ratios will change. So no answer. The ratios will will the ratios be same? No, the ratios will not be the same. Okay. Now, next a small note is, as the ratios are not same, we can change when we change the angle, we have a smarter way of representing them. As the ratios are not same when we change the angles, we have a smarter way of representing them. So what I mean over here is, see, tan of 30 was approximately around 0.57. But tan when it is 45 degree, it is 1. So how do you represent it? This way. Okay. What I just wrote now was unintentionally I wrote it off, but yeah, that's the answer. Tan tells that we are looking at opposite by adjacent ratio. 30 degree mentions that, okay, we are looking at a right angle triangle whose angle under consideration is 30 degree. When someone tells tan 45, the ratio will remain the same. The idea remains the same, opposite by adjacent. But the angle here is 45 degree. Okay, that is 45 degree. So basically, sine of some angle, we need to make a mention. Okay, it can be anything, right? Sine of angle A, cos of B, tan of theta. If you're not understanding anything as of now, please don't worry. We're doing a lot of questions on all of this. So now we're just looking at the concept on a on a brief note. Actually, it's detailed, but it's okay. You'll understand this practicals better once you do numericals and questions and everything. So there are a lot of it. The entire chapter it deals with it. The point is, this is a representation that's what you need to understand. It's a representation. It's a language. Okay. So all this is a language wherein we are telling tan means opposite by adjacent. 45 means it's an angle of the triangle which we are talking about. Right? Sine of 40 degree. Can you guys tell what does it mean? We are talking about the ratio. What ratio? We're talking about opposite by hypotenuse. So opposite to what? Opposite to the angle 40 degree. Okay. So that's what it means. So next thing that you can make a note of is tan of 30 degree is always fixed. Approximately 0.57. Not this is not the exact value. The actual value is 0.577, something like that. Tan of 45 degrees is always fixed. It's 1. So like this, you need to make a table and memorize it. Sine of 0, 30, 45, 60, and 90. Of course, there are infinite number of possibilities, infinite number of angles that you can put. Right? Example, sine of 30, sine of 465, sine of 2, 3, 4, 7, whatever you guys want. Any value you can put. And it is in your calculator. So in your calculator, there is something called a standard, scientific, graphic, and all that. You go to scientific. In that, you get trigonometry ratios. So I'll type in 45 degree. So tan of 45 degree is 1. See, it's fixed. So here in this table also, tan of 45 degree is 1. Right? This is the one. Tan of 45 degree is 1. So like this, you have 5 into 3, 15 values that we need to memorize. It's much, don't think too much about it. You guys will be using it a lot and I'll be teaching you tricks to memorize this. But I want you guys to know that all this is possible and it's there. So we need to make a small observation. That is, we have found sine of 30, cos of 30, and tan of 30. Are they same? Well, did our practicals actually make sense? Did we do it right? Let's see that. So these are the values that is tabulated by mathematicians and I just copied it. It's not from my end. So sine of 30 is 0.5 is what we got and half is 0.5. That's correct. Our observation, our practical was correct. Cos of 30 degree turns out to be 0.87. So root of 3 divided by 2, will it give the same answer? Let's see that. Root of 3 divided by 2 is equal to 0.87, correct. Then root of 1 by root 3 should be equal to 0.57ish, 6 and 7ish. Let's see what we got. What exactly is 1 by root of 3? 0.578. I mean 0.77, so 0.58 actually. But yeah, again, human error will always come. So yes, our practical was successful and we got a good, nice values, which is almost same as the actual values. Okay. So now what is the main thing that we learned? The main idea here is the ratios, these ratios, sine, cos, and tan, they called as trigonometric ratios, right? They have a fixed meaning. Sine has a fixed meaning, cos and tan has a fixed meaning. For a particular angle, right, in this case 30, the ratios, trigonometric ratios, have a particular value that we can memorize. And this helps in a lot of practicals. We actually use it in a lot of different places and it is useful. I'll show you one example, right? So then you will be able to appreciate. So we observed that the ratios are same because of similarity concept, and these ratios can be tabulated and this can be memorized and used as a lookup table. Lookup table is nothing but you make the whatever we just did, practicals, observation, cross verification, you do all of that, right? And you make a table telling that okay, if you see these are the values, and we can look on this table and write the values directly without thinking much. Okay, so that's your lookup table over here. And the idea is that sine is a just another name for opposite by hypotenuse. Like that, cos and tan. There are three more. Those are not tough, don't worry. If you learn these three, those other three will be much easier. And yes, throughout this chapter, we'll be doing all of this. So no need to think too much about any one of this. We'll be making use of it, right, repeatedly, and the concept will be very clear.